Okay, it's been a while since I recorded videos, but let's get back to it. This question is called all attainable values. So basically what the question asks us to do is we're asked to design a die that contains the faces from 1, 2, 3, 4, 5, 6. And basically when this die is rolled twice, we want it to be able to get the numbers that we can get the numbers from 2 to 12. So that's all possible to sum. So basically, how many ways are there to kind of make this die? So the idea behind this question is that, okay, we kind of have to start off with what we know, right? If we're trying to construct two die with six faces each from 1 to 6, then if we're to get two, that it means that we must have ones in our set. And the same reasoning goes for 12 with 6, because otherwise there's no way we can make that number up from other numbers, right? So 1 and 6 must be in the numbers. And the same for if we think about k is equal to 3 or k is equal to 11, then it must have been a 1 plus 2 or a 5 plus 6 combo to create that. So that must have meant that 2 and 5 are also in the set. So then we already have four numbers that are already set in place. We only have two more free ones to kind of change around. So that narrows it down quite a lot. And the remaining two, if we see what the sums have, is that right now the four numbers can create these numbers, and we're just missing 5 and 9 from this from the sum. So that means that we must have either 3 or 4. And just having one of them would satisfy the criteria, as 5 could be made from 3 plus 2 or 4 plus 1, and 9 could be made from 6 plus 3 or 5 plus 4. So it doesn't matter if we have 3 or 4, just one of the two is sufficient. So basically, the last number could be anything. So if we think about it, there are six ways to do it with three. So we can have a 3 and a 1, 3 and a 2, 3 and a 3, so on and so forth, all the way to 3 and a 6. And the same goes for 4. It can be paired with anything. And the thing is, there is one repetition where it doesn't matter if we're having a 3 or a 4 and a 3. So we have to make sure that we're not double counting that. So 6 plus 5 equals 11 ways. So there are 11 ways to design this die. And that kind of brings us to the end of this problem. I think the major thing for this is just to realize that the condition 1, 2, 5, 6 must exist so that it kind of narrows down how many possibilities you have. I think 1 and 6 definitely makes sense, but 2 and 5 are less intuitive, but still make sense. Okay, let's end it off here.